Alright, welcome back everybody to the Mind of Gabs. We are going to be doing video game design, Unit 2, JavaScript and graphics, video game design, Unit 2. JavaScript, and we're going to do general for loops all the way to loop and a half. Let's go ahead and let's get to these exercises. Let's see what we got left to do, ladies and gentlemen. We're going to start off with 2.11.5, and that's going to be count by sevens. Okay. Write a program that uses a general for loop that counts by sevens to 500. That should be easy enough. Now, function start, we're going to put our code inside of it. And let's just go ahead and use our already pre-given to us something, right? Let's go ahead and let's put that over. That way we can get rid of that. And we can put a little space here. That way we know what is going on. Let's see. We have to do from I to what all the way to 500. So we're going to make it from I equals 0 all the way to I equals 500. We're going to iterate not by plus plus. This is the thing, right? We want it to be I equals to I, whatever it was before. So we're going to start at 0. And then we're going to go by 7. So it'll be I plus 7, right? Now this would work. However, there's a shorter notation for it, right? So plus equals is that shorter notation. Iterate by stepping up by 7 each time. Cool. And then we're going to print line the I. Yep. Oh, don't worry about that. We're going to print the, and now what we're going to do is we're going to print out I. That's it. We're just printing out the value of I. If we run the code, looks like we're good. Check the code. We are good to go, ladies and gentlemen. We have completed part 1. Submit and continue. We are going to do the next one, which is going to be powers of 2. Powers of, let's see. Once again, let's go ahead and let's copy this. Control C is what I'm doing. Control V for paste. Tabbing that over. That way we can actually see what we're doing. So we're going to be doing powers of 2. Alright, so outputs 1, 2 to the 0. I think there's a few things that we can do here that's different. We can do 2. Let's see, powers of 2. Do this one. So 2 to the 0, 2 to the 1, 2 raised to the. I wonder if you can do 2 to the power. Let's look at our math right here. Have any way to do powers in here. So how are we gonna do this? First, let's change it. Less than a million. Okay. Million. I'm gonna put the comma in here so I can see it. Yep, that works. Okay, I'm gonna print out the value of something. 2 to the I. 2 times 2. So it's gonna. So the first value is going to be equal to. So it'll be 2. Let's just see. It'll be 1, 2, 4, 8, 16. So sum is gonna go up. 2 times 2. 2 times 2 times 2 times 2. So what we want to do is I wonder if there's like a mathematical operator. Yeah, check it out. Here we go. Check it out. There is a shortcut here. 2 to the power of. So 2 to the power of y. I equals I times our power. So this is our power of 2. So we did I equals I times. That's what we got to use right there. So we can actually do it right here. I equals I times 2, right? And that would be the equivalent. 0 is 1. Alright, let's do it. Cool. Yeah, actually, that's right here. I'm glad I saw that. Mathematical operators. Oh, wherever. I just got rid of it. Yep. So that's the equivalent of I equals. And then y, our y is 2. Easy enough. I just took that and just rewrote it there. print out I. Maybe that'll work. You know why it's probably taking a long time? Because it's a million. And this is actually going to slow. Oh my god, I shouldn't have done this. Because it's going to reiterate this a million times. Oh my Jesus. Okay, we're going to click refresh on this page. We're going to stop and then we're going to refresh this page. Yeah, we're going to stop that. And we're going to go back to that. Because that was too much work. Alright, let's just do the first 10. And it's still taking a while. God. Fast forward this video, right? So, note at home. Yeah, just don't run it. 1,000, 10,000, 1,000, a million. Let's check the code. Oh my god. I think I know the issue. Oh, 0 equals 0 times 2. That's 0. This needs to be a 1. Yes, it was. Yes, it was. Just, if you don't understand it, just move on, right? So basically I had a 0, which made it an infinite loop, and that was something that had been discussed at some point if you watch the videos. Infinite loops are things that never end, right? So the program will never end if it's like count it all, you know, like, and that was one of those things. First time, write a program that asks users for 2 numbers. Okay, and then we're gonna ask for 2 numbers. Let's go ahead and let's do that. Variable equals, and then let's ask for 2 numbers using a loop. Add all the numbers from the first to the second. Okay, read int. We should know that by now. Lowest. Equals read int. The highest. Cool. Using a for loop, add up all the numbers from the first to the second. So let's go ahead and let's copy this. Tab that over, and then we're going to say from first to second. Going to include the second? I think so. I think since it does include it. Okay, that's not what we are going to do here. So add all of the numbers. Okay, so I guess let's say we have to define a variable. Let's call it sum. Right? Equals 0. Okay. Actually, let's define that outside of it. That way, no matter what in the future, we know that it's all, the sum always starts at 0. And so then what we need to do is take the sum and then plus sum equals the original sum, right? So this would be the sum. This would be the sum as it starts, right? And that's this one right here. So the new sum equals the previous sum plus whatever I we are on. I bet you if we do that, it should work. So from 0 to 3, 3 plus 2 plus 1 is 6. Oh, I forgot to print out the sum. I apologize. I was supposed to say something. one. Okay, so it prints the sum every single time. I don't want that. I just want it to print just the final sum. So this actually needs to be outside of the for loop because I don't want to print it out. I want to print the final sum once the for loop has been closed. So let's run that again. 0, 3. There it is. Check the code. You are missing a semicolon. On mine's 2 and 3. Oh yeah. Oops. Always be forgetting those. Here we go. Submit and continue. We have our answer. And this is some wild up stuff we got on this right now. Okay, but we'll keep it in the background. Why not? Write a program that writes out in Factorial. Okay. It's gonna be wild. In Factorial. Okay. At least we're given that the end is 5. Write a program that writes it out as this, for example, for... I think we are probably going to use that exponential function that we used where we did 2 to the number, right? N times n minus 1. So this is going to be like an iterative thing. Oh, man. All the way to times 1. Okay, so... Okay, we're gonna want to use a for loop. And since Factorial, okay, we're gonna do the opposite. So I know it starts at n and it ends at n minus, but let's go from all the way from 1 to n instead. That way it just makes more sense in our brain. So it goes all the way from 1 to the variable n, and it's gonna plus each time. So now we need like a summation type thing. And then we're going to print out at the end its sum. So we're going to do the same thing we did. Print line, and we're going to print out its sum. Just like we did last time. So maybe we need to define that sum variable sum equals 0. We'll try that. We'll try the same trick we did on the last one, right? And we'll do that. So, sum equals the previous sum times the new I. That does make sense because if the sum is 0, 0 times anything is 0, and this is always going to stay 0. First one is 1. 1 times 1. Okay, so maybe if we change that to 1, that way it doesn't start off at 0. That looks good. Now we can, let's run that. Let's see how that looks. 24. 1, yeah, that's the right answer. 5 times 4. Okay, I'm missing something. Oh, I forgot to include the n here. That's what I forgot to do. Yes, there we go. That's it. Now you could actually rewrite this, by the way. You can rewrite this as sum times equals I. And that will give you the factorial as well. So those two are the exact same things, right? So let's comment this out. Right? The same as below. Line below. And if you check the code, it still works. Cool. That was a lot easier than I thought it'd be. It looked hard at first. Oh my god. So we're gonna... Oh my god. Okay. Oh, print. Okay. So these are... Thing here is we're gonna have the print line side of it. What's the best way to start this? Okay. We're gonna do a for loop inside of a for loop. Yeah. Crazy. I'm gonna do a for loop. Check this out. So here's our for loop. Okay. We're gonna do I all the way to sides on dice. right? That way you guys know what's up. And there's no 0 sides, right? It starts at 1 on this one because it goes from 1 all the way to 6, and make sure we are inclusive on 6. And what we're going to do is we're going to say that this side, all these are, like, it goes 1, 1, 1, 1, 1, 1, 1. So for all of the ones, for when I is 1, we're going to print all the sides. Check it out. I'll write the code and I'll explain the code here in a second. We're going to get rid of that line. I'm going to take that back so you know. All right, cool. So look, we have our for loop here, right? This is going to be from I to 6, and this one we're going to call J. So, J. And then J is all the way from 1 to sides on dice. Actually, let's just copy that. So here's what happens, right? So in this for loop, it's going to say for I equals 1, do this. So while the first side is 1, 1, 1, 1, these are for while I is 1, print out 1, 2, 3, 4, 5, 6. So it's going to run through all of the J's for 1 through 6, and then it'll end, and then it'll switch out and go to I equals 2, 1, 2, 3, 4, 5, 6, I equals 3, 1, 2, 3, 4, 5, 6, I equals 4, 1, 2, 3, 4, 5, 6, I is 5, I is 6, right? So it'll do 1, 2, 3, 4, 5, 6 for all of those. So what we need to do is we need to print line I, comma J, plus, don't forget the comma is a string, plus J, and then let's put, don't forget our semicolons there, right? I think that's all we need. Unexpected error. Did something wrong. Wrong. For I equals 1, check. I is less than or equal to sides on dice. J equals 1. That's okay. Oh, right here. Check it out. I forgot to change that to J. Oh, I forgot to put J here. Oh my god. Perfect. Alright, so there's your final code right there. And that's what it looks like when it's like made beautified. Alright, cool. So I had forgot to put the J here, and I forgot to change that out with J. Small errors. Rookie mistakes, Michael. Rookie mistakes. Alright, we're on 13.55. What's this one? Oh, we're going to do a randomizer. Write a program that rolls a 6-sided die 100 times and prints out all rolls. Oh my god! Alright, so it has a limited number, so that's definitely for loop. Right? We're gonna go from 0 to 100. Where's my for loops at? Because I hate rewriting those. Cool. Alright. Let's give ourselves some space so that way we know what we're doing. We're going all the way to 100, so make sure we change that out. Alright, what are we going to print out? Let's go back to this. There's a 6-sided dice and print out all the rolls. So we have to use a... Okay, so look. Here's our randomizers, right? They're randomized integer between low and high. So our rolls a 6-sided dice. So we can actually use this one right here. Right? Use the randomizer from 1 is low. The high is 6. So we can use that. That's good. That's a good start. Now we actually have to give our variable something program that rolls. So let's use variable roll equals randomizer. Our roll is going to be randomized, the random integer between 1 and 6, and we are going to print out that roll, and we're going to do that 100 times, like, I know the easiest way possible here, honestly.
Calm is a state of
So let's do this.
It's the familiar,
Like that needs to go.
the trusted,
Run the code.
like the classic orange juice monster flavor.
Check the code.
What is
Code's
life
good.
without a little
Code
kick?
is good.
Everything's exciting. Pick up a can of Juice Monster Chaotic today.
Easy enough. Alright, next up. Run the demo. What's so special about this? Oh, it's just gonna randomize the color. That's it. It's side length 100, okay. Doesn't seem to be too far. Write a program that draws a random colored square on the and then entered. So we're gonna have to do the get width and get height thing again because we're gonna have to make sure it's half of the width and half of the height. The sides of the square should be side length. Alright. What we really should do is just remember what we did with the circles. So, variable X position. And then we're going to do variable Y position. And we want it to be equal to half of the get height. Oh, wait a second. Right. And then this one is equal to get width. 5 by 2. Okay. Go ahead and let's get our rectangle. Don't forget to add rectangle. Add rect. Alright, cool. Let's see. Well, the color is not going to be color blue, so it's actually going to be randomizer. Copy that. Put that inside of the random color. Alright. Space. And we actually don't need that. So we have our random colorizer. Don't forget that you need that extra there. Set position would be at X position and Y position. And oh, side length. Oh, definitely doesn't look like not centered. Oh, it is centered. Okay, okay. So we got a center here. So a circle gets centered here, but for a square or rectangle, it positions it up here. So we got to go down half of its length and over half of its length. So this is its call this its height, call that its width. So we got to go down half its and down half. Okay, so we got to go down. Remember, both of them got to go down. And both of them are half. So both have to go down half. And then, well, its side length is the same for both, because it just so happens to be a square. Alright, check it out. Alright, they look centered now. Good. Good. Alright, cool. Cool. Perfect. 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 That's why we had to do those. Perfect. So if you guys actually fast forward it to here, go back, and you'll see me going through and explaining why I actually had to put those in. And you'll see me actually run through that. Alright, where are we up to next? 213? Are we on inventory? 214. Oh, 214. So that means we actually don't have that many assignments left. Cool, we are running through these. Cool. Oh my god, okay. So. Oh my god. Oh my god. So we write a program that keeps track of a simple inventory for a store while there are items left in the inventory. Ask the user inventory while there are still items left. So we're gonna definitely put a while. While I don't know, put number of items greater than 0. That means while there are things left, right? We are going to prompt how many items would you like to buy? That's what it says. While there are still items left in the inventory, ask the users how. Okay, so we're gonna copy this. We're going to print line. How many items would you like to buy? Wait a second. No, that's wrong. That's wrong. Why do I know that's wrong? It asks them how many they would like to buy, and then they have to specify it. So this actually is not a print line, that's a read int. It's saying how many would like to buy. Enter a number. Variable like to buy. I think it's something that I know. I'll get rid of this. Variable like to buy. Cool, but it actually says we have blank inventories left. So this is print line. Then it says we have blank number of items left in the inventory. This number of items. Oh, that's funny. I was actually gonna have to define it, and I just randomly chose number. That's funny. I didn't even see that there. That's funny. I guess, you know, we think alike. It makes sense, right? Starting items. Wow, that's greater than 0. Print out. Do this one time. First thing we do is print out. Oh yeah, I forgot my semicolons at the end. All right, print out. We have blank number of items. How many would you like to buy? And then what we have to do is subtract it. So we're going to do number of items. The new one equals the previous one minus like to buy. And we can shorten that by saying number of items minus equals like to buy. That would give us the new number of item. Right. Alright. How many items? Like to buy it, and then it says we now have. So then we need to print out. Print ln. Now we have space plus number of items plus space left. However, down here, right? They have one item left. By one, it doesn't say we have. So this is going to be an if statement. If the number of items is greater than 0, we're going to print we have number of items left. Else What if... It doesn't say all out, because, like that, there's not... Like, I was thinking, like, what if there's not enough? Oh my god, okay, this is actually harder than I thought. Wow, the number of items greater. Okay, this is actually going to be our print line. Down here where it says, all out. Right? Why do I say that? Because this is our while loop. While number of items is greater than that. When that runs out, it's going to say print all out. So... the number of items is greater than like to buy. Ah, this is tough. Greater than like to buy. Print out this, else if it's not greater than. Else if else greater than or equal. Might run into an issue with that. It's less than that. So if the number of items, right? So if if I want to buy more than what they have, we're going to print the line. There is not enough inventory for that purchase. Okay. We're gonna need to get rid of this line. I'm gonna control X that. So here's what's gonna do. We're gonna print a line that says we have X amount of items left in the inventory. How many would you like to buy? We have 6, and I would like to buy 8. Well, listen here, my fine friend. Last name done right. Well, sir, we have 6, and you would like to buy 4. We now have, let's do one at a time. Alright, alright, we have 6 left, and you would like to buy 4, please? Thank you. Alright, so what we're gonna do is we're gonna say, so, we're gonna take the number of items that we have, and we are gonna subtract it from how many you would like to buy, and we are gonna say we have X amount left. So, thank you very much for your time and for your inventory purchase. So this is, we have more than you would like to buy. We're going to subtract those. Now we have blank left. Alright, sir. We are not going to do anything with that. Please do again. I don't know if I'm missing. I'm probably... we have 20 left. Let's do 22. Nice. 15. 5. Did that work? No. Don't tell me that. God, I can't believe that worked. Really on his first try. Oh my god. Okay. Yeah! Alright, cool. That is the final solution, ladies and gentlemen. Cool! I'm running out of time. I only have a few minutes left. I might have to end it on the Fibonacci. Right? I might have to do... I have 8 minutes left in class that I can do this for. Alright, cool. What we're gonna do is Fibonacci. 1, 1. Oh my god, how am I gonna do the Fibonacci? Sums it plus. We're gonna print out the numbers in the Fibonacci sequence up to the max number. Figure out the next in the Fibonacci sequence by adding up the numbers. Off. Is that one 1 or is that one 0? Okay, so it has to print out. First thing it's gonna do is gonna print out. It's gonna print out third equals 0 plus 1. 1. First and second are ever changing. They're gonna be changing. So every time we iterate, it's gonna go one step higher. Which means after we iterate, first will now be the second number. Yes, the first will be the second, third. And that'll reiterate that way. Oh, God. Alright, because as we go up, so like this is the first, and this is the second, this is the third. Right? Now I gotta print out this number. This number being the third number now is second, first. So like let's say we're at 21, that's what we want to print out. This is the second, this is the first now, right? So it only counts for the previous two. So if I want 34, it's 12 plus 13. If I want 144, it's 89 and 55. So I have to like make them step up after I've added them together, now step up. Add them together, now step up. I have to, what am I gonna print out? For loop. I equals oh. Might wrong. Probably doing it wrong. All right. First one. Okay. I can't believe that worked. Oh. So I noticed that first I need to print out 1. So their third number equals the second plus the first number. Second, so this is 1 plus 0. That equals 1. So third equals 1. Right? And then, so this is 1, 1, 0. Now this is 1, that's 1. So now 1 plus 1 equals 2. And now this is 2 and 1. 2 plus 1 equals 3. 3 plus 2 equals 5. So this is 3 and 2. Yep, that worked out. I can't believe it worked out. And that's where I'm going to end it today, ladies and gentlemen. I'm not going to do 2.1 to 2.15. Maybe I can't. Maybe I can't. 2.5. That was right about the ring, man. Wow, they don't equal. It's gonna take me some time. All right, yeah, I'm gonna do 2.15 on the next one, ladies and gentlemen. That's gonna be it for now. I'm gonna do 2.14. Peace.